Hi, my name is Donnie, and last time we saw how to summarize the data in terms of numbers, for example, average, median, range, variance. Today, we're going to be summarizing the data by its positions. When we have a set of several values or data, we sometimes measure in what position a certain data is in out of the total. For example, measuring who has scored the most in football would be ranked by simple rankings. Other cases, such as grades or evaluating college applications, will be ranked by percentiles. In total, there are three ways to rank the data. The first is simple ranking. It's a ranking of a value when the set is displayed in an order. For example, whether it's 7th out of 40 or it could be 20th out of whole 100. Next is the percentile ranking, which is a ranking of a value in percentile. For example, a data could be displayed as 86% as written here, or it can be 24%. Anything that is calculated as a percentile is a percentile ranking. The advantages of percentile ranking is that it can compare data that has different bases. So it can compare two data that are in a different sets, and we can compare each and see which one has much more advantage or etc. And the another advantage is that it is useful when we do not know the exact population or when it doesn't matter. Because you percentile everything out of total, the exact number of population actually does not matter. The diagram we see here is a box plot, as we all know, and the reason why I put it here is because it is the good example of a diagram that uses the appliance of the percentile ranking the most. The box plot is a standardized way of displaying the distribution of data based on the 5-number summary: minimum, first quartile, median, third quartile, and maximum. The first quartile and the third quartile are based on the 25th% of the data and 75th% of the data, and median is exactly the data that lays upon the 50% of the whole set of data. Lastly is the z-score. The z-score shows how many standard deviations the value is away from the mean. The way how you calculate is you subtract the mean from the value data x and you divide that by standard deviation. If you use it the other way, then you can figure out what the x is. X can be equal to the mean plus z-score multiplied by a standard deviation. Now, for example here, let's say we have a data of mean of 5 and a standard deviation 0.2. The z-score of 4.96 would be -2 because it is 2 standard deviations lower than the mean. And similarly here, z-score of 5.02 will be +1 as it is 1 standard deviation further to the right from the mean. This is how you use z-score. So how do we rank a data with a z-score? We do it by using the empirical rule. The empirical rule, also known as the 68, 95, 99.7 rule, shows us the range of data by using the standard deviation. The empirical rule states that all values within the 2 standard deviation spans +1 and -1 are the 68% of all values. 4 standard deviations are 95% of the values, +2 and -2. And lastly, 6 standard deviations are within 99.7% of the values. This rule applies specifically only to the bell-shaped distribution, as you see here. So, by using the empirical rule and the z-score of the data, we can easily figure out in what percentile the certain data is within. These are the 3 rankings in summarizing the data.